is 3.7 that we didn't manage to finish yesterday. So what I'm going to do now, I want to do 3.7. Then after 3.7, I think also try to manage to finish 3.8. Yeah, 3.8. Someone also asked me to do 3.8. So I'm just gonna do this uh in a single video so that you guys can understand. So actually here it's our, okay, here it's our 3.7. So 3.7 says a ping pong ball weighs 0.025 Newton. So the ball is placed inside a cup that sits on top of a vertical spring. So if the spring is compressed 0.055 meter and released from rest, so here the point is, you have been told that the spring has been released from rest. This part here. From rest. So the maximum height above the compressed position that the ball reaches is 2.84. So ignore the air resistance and determine the spring constant. So now we've been told that we should also uh, determine the spring constant. So as you know that the spring constant, we're likely to get it on the force, resonating force, also the displacement of the spring. So now on this part, we're going to say, remember, we've been required to find the K. So we have the force, which is there is restoring force, which is equals to the K times X. So remember, we've been told to find uh, the spring constant. So the spring constant is this K. So we're going to say that F divided by X is equals to K. That's why here on the answer it said 47 Newton per meter. So remember, the statement also that we read. So the spring, actually, if you can check here, they say this spring is compressed to 0.005, sorry. So actually, so the ball managed to reach the maximum height above the compressed position that the ball reaches, which is 2.84 meter. So remember, here we are going to talk about the mechanical energy. So the mechanical energy, where is conservative energy? So remember, we have mechanical before, and then we also have mechanical after. So now I'm going to talk about the projection. As you know, we're going to talk about the projection. So firstly, we're going to remember, if you can remember, we managed to talk about the conservation of elasticity, which is this part here where we talk about the conservation. So this formula, we're going to apply it there. So we're going to say that so we're going to say that um okay, so 1 over 2 the kx 1 squared. So remember, the ball said was released from rest. So now we are not going to have that 0 or that 1 over 2 mv, which is kinetic energy, which is going to be 0. What about the height? So the height is going to be 0, remember. So the height for the potential energy is going to be 0, equals to. So when we go to the other side, now we're going to level something. So remember, the ball is going to reach the maximum height. So which means also the velocity is going to be 0 for, okay, so for, remember, for this one we're not going to have the spring when the ball is already released, so it's going to be 0. And then what about for the kinetic energy? So kinetic energy is going to be 0 because the velocity is going to be 0 on the maximum height, so which is going to be um 0 also. So what about the mg? Remember, we need to find the mg. So the mg h. So we already have the height. So we already have the gravitational acceleration. We already have the mass. We're going to get the mass. Obviously, this, remember, mg is equals to weight. So we already have the weight. So uh, I don't think we should get confused there. So remember what's needed. It's k, which is the constant. So we're going to say that our formula is going to be 1 over 2 kx1 squared, and then equals to let me write the weight times height. As you know that mg is equals to weight times height, so I'm going to say that remember we need k, so I'm going to multiply both sides by 2, so which is going to be k x1 squared equals to the weight is going to be 2 weight and then height. So we need x there, so we're going to say k equals to the 2 times weight times the height is going to be divided by x1 squared, right? So now we need k, so now we're going to substitute. We're going to have to, what about the weight? The weight will go back to the to that we have been told that 0.025, so it's going to be 0.025 and then times the height. So now we're going to check the height. So the height is 2.84 meter, so which is going to be 2.84 meter. So divided by, remember, the square of uh the spring okay, the compressed or the displacement of the spring, which is 0.055, it's going to be 0.055. Then now we're going to punch our calculator and then we get the answer. So our answer from the calculator is going to be 46.942. Remember, Newton per meter. So from that point, now we're done. So we're going to face on the next question. So the next question is supposed to be 3.8. So let me check. So now we need to focus on 3.8. So our 3.8. Okay, so 3.8 is here. I said I'm just gonna do it up on the same so that we can finish earlier. So 3.8 says when a 19.6 Newton block, remember a 19.6 Newton block is suspended from a vertical hanging spring. It stretch oh okay, it stretches the spring from its original length of 5 centimeter to 5 centimeter. So which means now the spring is compressed to compressed by 0 or okay, let me just use by 1 centimeter. If you can check here, compressed by 1 centimeter. That's why here I have been told that its original length of 5 centimeter to 6 centimeter. So the same block is attached to the same spring. So the same block is attached to the same spring and placed on a horizontal frictionless surface. So the block is then pulled. Remember, so now the block is it so? Yeah, the block is then pulled so that the spring stretches to a total length of 0.10 meter. So now the block is released at time t equals to 0 seconds. Let's hope I'm not mistaken there. And undergoes simple harmonic motion. So as in the sketch, so what is the frequency of the motion? So now we've been required to determine the frequency. We should pay more attention about now. We are required to calculate to determine the frequency, the frequency of the motion. So from this part, remember we've been required to calculate the frequency. So let's check this original length of 5 centimeters. So which means the original length of 5 centimeter, and then remember stretches from its original length, which was 5, and then goes to the 6. So now the difference 6 minus 5, which is going to be 1 centimeter, and then 1 centimeter is going to be 1 divided by 100. So as you know, that's going to be 0.01 meter. So from that point, you have been required to calculate the frequency. So remember, we need to find the mass from this the angular velocity is k divided by what, by mass. So from there you are going to find the k. So the k is going to be the force divided by the displacement of the spring, which is going to be that. So the k is going to be equals to the force is 19.6 divided by 0.01. So you're going to get 19 or 1960, and then what about that divided by 2? So these two we are going to get 2. Okay, it's fine. So let me not confuse you. It's not Newton per meter. So from that point, let me try to use this side so that we can have. So our constant is remember, it's 9. Okay, it's 980 Newton per meter. That's it. So that's correct. So this is our constant. Just confused by minus thing there. So from that part, our constant is 1960 Newton per meter. So from that part, um, we need to find the frequency. So to find the frequency, we also need to find the angular velocity. So from that part, the angular velocity is equal to the root of k divided by mass. So let's find mass. So our mass is going to be remember weight is equal to mg, as you know. So we have already have the weight, we have the mg, so we can even find a mass. So it's going to be the mass is equal to the weight, which is 19.6 divided by 9.8, so which is going to be 2 kg. So from that part, now we can find our angular velocity. So which is the angular velocity is equal to the root of k divided by mass. So this is equal to the root of the k. So our k is 1960 divided by 2, so which is going to be the root of 980 from that part, and then this is going to be let's punch the calculator. So 19 okay, root of 980 is going to be 14 root 5. 14 root 5. Remember, we need the angular. Oh, we need the frequency. So as you know that this is the angular, so we know that this is still the same as 2 pi and then f. So that 2 pi f is going to be 2 pi the frequency was to the 14 the root of 5. So the frequency is going to be 14 root 5 divided by 2 pi, and then this is going to be let's use the calculator there, 2 pi, so which is going to be 4.9823 hertz. So let's check the next question. So the next question says what is the speed of the block, okay, the speed of the block each time the spring is 5 centimeter long. What is the speed of the block each time the spring is 5 centimeter long? So now we need to find the spring when it is 5 centimeter long. Remember 5 centimeter from this part here. So now we want to go back to the statement. Remember, lastly, when we had a class, I said that when you saw the something called the frictionless, you should think about the conservation energy, which is mechanical energy. So from that point, you know that we're going to have the make before and then make after. So we're going to the other side. So to the other side, going to say that as you know that it's going to be 1 over 2 k. So let's try to check again. So they say what is the speed of the block each time the spring is 5.0 centimeter. So remember uh from its original length of 5 centimeter to, so now we're dealing with the 5 centimeter and the maximum of the maximum, which is this, is going to be amplitude. This is where the spring can stretch. So now from that point we're going to say that the 1 over 2 the k x1, remember, then I don't have velocity, is going to be 0, don't have the height, is going to be 0, equals to the 1 over 2 again. So here we're going to have k, and then what about that, and then we're also going to have this supposed to be square, and then also this is supposed to be square, and then plus 1 over 2 mv square. So you should remember about that part. Remember we need the speed. So from that part we're going to say take this half away, and then gonna take this one to the other side. We are going to level with mv squared is equals to k, gonna take k into x. So this x1 is going to be our amplitude. So where this the spring can go, it's going to be a squared minus x2 squared. So in that part we're going to divide with the mass. Remember we need speed. So this is going to be k divided by m times a squared minus, so this is supposed to be minus x squared, and then so this supposed to say v equals to the root, so this is supposed to be the root of k divided by m into a squared minus x to x squared. So that way, so you know this one is a singular velocity, so you can even write the angular velocity and then say the root of a squared minus x squared. So from this part now we can substitute. So now we need to substitute. So we're going to say that this is was our 14 root 5, 14 root 5. So the root of our amplitude is going to be 0.1 squared minus into the 0. Remember we're talking about uh, the h. So remember, well, what is the speed of the block each time the spring is 5.0 so long, so which is going to be 0.05 and then squared, and then now it's going to be from that point it's going to be let me punch my calculator, then I'm going to get the 2, so let me confirm, don't want to write nonsense, 14 or root 5. 14 root 5 is going to be, I managed to get to 0.7111, and then meters per second. So that's gonna be your speed. So now the last question says what is the maximum acceleration of the block. So now you have the amplitude, now you already have the angular velocity. So now you just need to take what's yours? Sorry. So now we're going to say that the maximum acceleration is equals to the amplitude times the angular velocity squared. So this is going to be 0.1, and then into, remember, this was 14 root 5, and then all squared. So this is going to be 0.1 into 14 root 5, and then sorry, root 5, and then all squared, squared, and then I managed to get 998 meters per second square. So here mostly I think they got is it 91, let me not go away, I think it's 91.9, is it, so 97.1 or 0.91 meters per second square. So these are still the same as this one. So just that here I didn't change it into that 13.304 meter right per second. That's why maybe I've got exactly 98. So let me try if I try to put that 31. So sorry, supposed to be 31 here. 31.304, so that I can get. So I got 97.994. So in that way, so that's what I'm getting mostly. So I still have the same answer, so nothing that much. So from that part, 98.98 meters per second square. So that will be your 3.7 and 3.8. So from that part, I think now we're gonna focus on unit 4, which will be okay. Try to check. I think it's all about the ideal gases, the ideal gas law, and the kinetic theory. So from this point, you should also know about the deformation. So the deformation is we're going to deal with the elastic deformation. So here we have Young modulus. So Young modulus, they are perpendicular to the area. So to the area. So your area should be that on that point, and then your force should be in that point. So it should be perpendicular to. So remember, you should also know about that. So from that point, sorry, and then from that point, just wanna fix something. Thank you. So from that point now, we also have the shear deformation. So the shear uh, modulus, which is this, which is also parallel to the area. So if we can check here, we have our area, and then here we have our force to the other side. So and that way. So and then we also have the bulk formation. So remember also this, you need to know that this is a pressure. This is a pressure. So this pressure, as you know from fluids, so it was F divided by area. So force exerted on a certain area in the part. So if you can check here, same as this one, just that this is a change in pressure, which are the final pressure minus the initial pressure. So this part we have the stress. So the stress, we talk about the pressure, and then we have the strain. So on certain questions like okay, let me check. Soon as a 10 question like let me, okay, so like still looking, okay, so from let me just say from this part, just it's all about that. So here you have been required, so a 500 Newton object is hang from, so which this is a 500, Newton. Object is hanging from the end of a wire. Of course, they also give you an error. So now you already have the pressure. So now you already have the pressure. So the wire stretches from its original length. So remember, this we are talking about the length. So when we talk about the length, we talk about the Young modulus. Young modulus. Talk about the Young modulus, which is going to be R divided by R, the initial length. So that's why they say the wire stretch from its original length. So its original length is this, which is initial length to 200 uh 200.50 centimeter. So which means you're going to say, remember there's change in L divided by uh, the original length. So you should also know about that part. So they say determine the Young the Young's modulus of the y. So now you need to find that y. So as that, easy as that. So the brick are also 3.13. So the brick shown in the drawing is glued to the floor. So the brick is lowered to the floor. So at 3,500 Newton force is applied to the top surface of the brick, as shown. If the brick has a shear modulus, so here they give you the shear modulus. Also, they managed to specify which modulus are they. So this is a shear modulus. So they say how far to the right. So remember, this is an area. This is a force. This is the force exerted to. So this, which means this and that are parallel. So you know we're talking about the shear modulus, which are parallel to forces parallel to the area. So how far to the right does the top face move relative to the stationary bottom? So remember, they need to know how far okay, how far to the right will this. So now they need the change in x. So now they need the change in x. So remember on the other there was something like this. So this one gonna move to the other side. So this when it move to the other side, this is gonna be the same as this part. So they need the change in x. It's all about it. So now they're going to say that okay, so find stress. Okay, as I said, find stress, strain, and Young modular. I said stress is what? It's pressure. And then strain is what? They are it's the the change in length divided by the initial or the original length. So also the Young modulus, as you know, the Young modulus you managed to find, which is also the pressure. So also to the other side, now we are talking about the radius of the sphere of the lead. So now here you're given the pressure of the lead, which is 1.000 meter on the surface of the earth, where the pressure is 1.01 times 10 to the power 5 newton per meter square. So the sphere is taken by submarine to the deepest part of the ocean to a depth where it is exposed to a pressure. So it's 1 point. So now here I've been given a pressure. Again, what is the volume of the sphere at the bottom? So remember, you should think. Remember, we talk about the changing pressure, which is the P final minus the P initial. So here you have uh, remember the initial, and then so okay, it's fine. So here you have the final pressure. So is it so the final? Remember, this one's supposed to be high, and then the other one's supposed to be low. So this one's gonna say is the PF, and then this is the PI. So you are going to find the change in P so that you can find the pressure. So what is the volume of the sphere at the bottom of the ocean? So now remember they need the volume. So now we're going to talk about the change in V, also the V initial about it. So you should also know about that. So remember, initially they gave you that length. So you also need to find the area, or not the area, but the volume of the field. So there is a formula for the volume of sphere. If I'm not mistaken, it's 1 over 3 pi r square. Yeah, pi r square, not really. It's pi r squared and then something. I'm not sure, but you should go and figure it out. So from that part we're going to say that okay, now nextly we'll be dealing with learning unit 4, which is going to be chapter 14 on the textbook, which is going to be the ideal gases law and kinetic theory. So we're gonna be talking about the molecular mass, the mole, and the Avogadro's number, the ideal gases law, the kinetic theory, and diffusion. So it's all gonna be that.